I'm Anil Kumar, and in this video we will learn how to do partial fractions when denominator has a cube. Right? So we'll understand the technique first and then we'll solve this question. So I could write this function x squared over x plus 1 whole cube as equal to a over x plus 1 plus b over x plus 1 whole square plus c over x plus 1 whole cube, right? So that is how I can write. Now if I multiply both sides by x plus 1 whole cube, I get x squared equals to a times x plus 1 whole square plus b times x plus 1 plus c, right? That is what we get. Now we have to solve for a, b, and c. So let's make some substitution one by one. So if I substitute x equals to minus 1, I get the value of c. So if I write x equals to, let me write here, for x equals to minus 1, I get minus 1 whole square equals to, and this will be a times minus 1 plus 1, which is 0, right? B times minus 1 plus 1, which is 0. So we get the value of c as 1. So from here, we know that c is equal to 1. So we get the value of c. Now, to find a and b, what we can do in this particular case is that we just open and compare the coefficients, right? So c is 1. So let's just open this up and then compare the coefficients. Now as you can see here that x squared term will be only with a, right? So x squared term will be with a, and here we have x squared on the left side. So if I open this up, which is we have x squared term here, a x squared. So a has to be 1 if you just compare, because okay, let's do that expansion. So what you really get here is that a times x squared plus 2x plus 1 plus b times x plus 1 plus 1, which is c. So if you open this up, you get ax squared plus 2ax plus a plus b x plus b plus 1, right? So that is x squared. Now the coefficient of x squared should be same. So comparing that, you get a equals to 1. Do you see that? So a is also 1 for you. Now if I substitute a as 1 here, we can find b, right? So getting back to our equation, so we write back as x squared equals to a is 1. So it gives you x squared plus 2x. We are substituting a as 1. A as 1 means plus 1 plus bx plus b, right? Plus 1. Right, so that is what you get. Now in this equation, 0 equals to bringing x squared this side. The coefficient of x is equal to 2 plus b, right? So 2 plus b times x, we have added these, and the constant is plus 2 plus b, right? 2 plus b, correct? And clearly from here, 2 plus b is common, so we have 0 equals to 2 plus b, and within bracket we get x plus 1. Now for a value of b equals to minus 2, this will be 0. So b equals to minus 2. We'll always make this equation true. So from here we get the values for a, b, and c, right? So these are the values. So based on these values, we can rewrite the integrand, and we can write this as a over, so a is 1 for us, so 1 over x plus 1. B is minus 2, so minus 2 over x plus 1 whole square. And c is 1 for us, so plus 1 over x plus 1 whole cube dx, right? So that becomes the integrand. So this is how we could write this as a partial fraction, right? So that is how we could write this as a partial fraction. Now you can write down their integrals individual and add them up, right? So let's do that part. So the first one here is ln, right? This one is ln absolute value of x plus 1, correct? Now this goes to the power of minus 2, so it'll give us minus 2. And since that is to the power of minus 2, when you add 1, you get minus 1, right? So you get minus 1. And minus 1 you divide by, so you get this as plus 1. So you get the equation as 2 over 1 over x plus 1. Is that okay? Now for this one, well, let me show you this one. So this one should be to the power of minus 3. So if you add plus 1, you get minus 2, right? And then you divide by minus 2. So this becomes minus 2. And this becomes 1 over 2 times x plus 1 to the power of 2. Is it okay? Plus c. That is how you should be doing it, right? So what I'm trying to say here is this you could, I've just avoided that step. Anyway, don't worry. Let me redo it. Okay. So for some of you, that may be beneficial. So let me redo this one. So from here, what I'm trying to write here as this. First one is okay. So you can say this is 1 over u, and the du is dx. So that's fine. So let me write this as 1 over x plus 1. Right, okay. And here I'm writing this as minus 2. X plus 1 to the power of minus 2 plus we are writing this as x plus 1 to the power of minus 3, all this dx. Is that okay? Now the derivative of the first one is ln absolute value of x plus 1, and here it will be, let me write all the steps, 2 times this becomes x plus 1 to the power of minus 2 plus 1, which is minus 1, divided by minus 1, correct? So that makes this positive. Here it will be plus x plus 1 to the power of minus 3 plus 1 is minus 2 divided by minus 2 plus c. Is that okay? And now you could write this as ln absolute value of x plus 1 minus minus becomes positive, and we could write this as 2 over x plus 1. Perfect. Minus and plus becomes negative, and you get 1 over 2, x plus 1 whole square plus c. Do you see that? So that becomes your solution. So this is your solution of your equation. So whenever you have n powers, in this case it is 3, you could actually split them up like this and then solve your equation. Correct? So that is how you could do it. I'm Anil Kumar, and I hope that helps. Thank you and all the best.